Okay, here's your explanation. First of all, I'd think of this 9 as 3 squared, because then I got a property that says those two are the same. The answer's 2, so it's just 2. Okay, number 2, condensed to 1 log. Obviously, it's going to be just 1 log, so I'm going to write that log. What base do you think it'll have? Of course, it'll be base 3. Then the only question is, what do I do with these? And maybe even more importantly, these. Well, those go up as powers. But remember how we talked about this the other day? That is not 2x to the 4th. Remember that? It's not 2x to the 4th. It's 2 to the 4th and x to the 4th. Okay? So 2 to the 4th is 16, x to the 4th. And since there's a minus here, this will be divided by 5 squared. And I'd totally be fine if you said 25 there. I could have messed that up, but I think I got it. Raise your hand if you had the same thing as I did. All right, good. Okay, this next one is where this same deal goes up here. It's called the power rule. And now I'm going to condense these down into 1 log, because if you can condense it, you should. So log base 2 of x squared. Oh, they don't have this. Ooh, I didn't mean for that to happen. That means you probably wouldn't be able to solve this one. And I apologize. I meant for this to be base 2. You guys could have asked me if that was an oops. And it was an oops. Sorry. And now we'll put the 3 here. And that equals 1. And I don't think you could have done it the other way, honestly. So 2 equals 3x squared. By both sides by 3. And x squared equals that. So then if you're really smart, you know that there's 2 answers to this, because this is the absolute value of x, and it's plus and minus the square root of 2/3. But if you're really, really smart, you'll go back and check that negative answer and find out, oh, wait, that negative answer is in the argument of a log, so it can't exist anyways. So now we're back to square root of 2/3. Yes?
So, like, if it was just 16 over 25, then you could square it off, right? So, do you, like, square, when you square root the numerator and the denominator, like, does it become, like,
Okay,
4x?
from my experience, once we change the problem, everybody gets really confused. So I don't want to change the problem. If you want to give me a different problem to do and talk about, I will, but I don't want to change this question, or people will get confused when they hear the answer. Okay, so why don't you think up a new question that you want me to do that would involve your issue, and I will help you with that. But I'm not going to use the same question.
Okay, so if it was log base and 64 times x to the 4th in the numerator over 36, would you simplify it? Would you like square root?
Okay, the question is, would you simplify? Yes, you would absolutely simplify that, because these are both even and they both have factors in common. So I'd definitely simplify that down. Yes, you should simplify these as much as you can simplify them. Okay, all right, moving on. Got a lot of topics to cover, so if I'm brief, I apologize, but I do have a lot of things to cover with you. Next thing I want to do is what if you've got weird fractions in your problem, like you would if we had this. Let me think. Now, I don't see any fractions, Mr. Server. Oh, wait, log base 2. Usually they'll be the same base. Could you ever have a different base? Yeah, but then if it had a different base, it would have to simplify away. So like, let's say this had been base 3, then there'd have to be like a 3 there. Because at the end of the problem, they gotta have the same base. Okay, so there's your problem. Everybody try to solve that one, and it's gonna have issues because there's x's all over the place. But you can solve for it. I'll pause for a second when we give that a try. You're gonna notice in today's folder, in the Schoology folder, that there's a bunch of stuff in there. I'm not requiring you to do anything, but if I were in your shoes, I'd want some practice problems to do. Just kind of giving you a bank of practice problems that are there, and then there's an answer key for them. None of that is required. But as you know, the test is tomorrow. Practicing it tonight will make a big difference. All right. Let's see. Henry, can you tell me the first step here?
I would put the logs on the left side into one log.
There's a word for that starts with a C.
Combine.
Close, condense. All right, so we're going to log base 2 of, what do you think that condenses to?
X over x minus 4.
Yep, and all that's in the argument. Equals log base 2 of x. And then, yay, what happens that helps a lot here? Jacob, what's next step?
You can cancel out the log base 2.
Okay, I got x over x minus 4 equals x. Now what? If you can factor it, you should. Is it that one? No. What is one of those rules? Clear fractions. Times it by x minus 4. And all of a sudden I have x equals x squared minus 4x. Could you have to solve that? Yes. The first step is always set it equal to what? 0 minus x. And I have 0 equals x squared minus 5x. And a lot of people get stumped right there because, like, that looks weird. It's only got 2 terms. If I was even going to do the quadratic formula, it's like it doesn't have an a, b, and a c. So what do I do? Yes? Oh, you mean factor it?
Yeah.
Yes, comes up every time, doesn't it? And then the answers are 0 and 5.
0 is actually.
What if I was skeptical, like, uh-oh, is there a chance one of those is wrong? What should I do?
Put it back in.
Put it back in. Can you have a 0 right there? No, because log of a 0 isn't allowed. I could put it there too, and I can't have a 0 there. You have to have positive numbers. You can't have a 0 or negative numbers. So that's out. How about the other one, the 5? Is that okay?
Yeah.
5's okay there, and does 5 mess up this part? No. 5's also okay there, so yay. That one actually works. So that's a good example of what kind of solution? Extraneous. All right. Next thing. ln of x to the 4th over e m squared. I want you to expand that to 2 different logs. It's currently 1 log. Make it 2 or even 3 logs. But the directions are always on these expanding ones. It's expand and simplify. So if there's a chance to make something simpler, like, oh, 4 over 4, it cancels, make it simpler. A lot of kids are going to get, oh yeah, this must have been this log plus this log, but they're going to miss either expanding it all the way, or they're going to not notice that, oh crap, this simplifies down to just 3. Okay, so look for the chance to expand it all the way and the chance to simplify it. Good luck. Okay, let's see if you expanded it all the way. I know you knew that it was log base e, but some of you made the mistake of saying ln. You thought you were being smart, but you weren't. Because if you break it up as log base e, you're going to do something that other kids won't. I said anytime you see ln, break it up as log base e. And then there's this x to the 4th. And then some of you were smart enough to know that that 4 should go to the front. Yeah, you have to do that to have it be expanded all the way. And then since this is divide, then I have minus. And another log base e. And then e. And then I got, wait a minute, I got a times there. For now, I'm going to just write em squared. It's a really common thing for kids to think they're done right there. And then there's some kids that go, oh, wait, the 2 has to go down in front. And then they think they're done. Not done. Tyler, where am I? Could I not be done right now?
You could expand the log base em squared.
Yep, that can definitely expand further. And now watch this. Remember me saying that parentheses and negatives take up so many points in this class? you now need a parenthesis around this. Otherwise, this negative won't distribute to both parts. Log base e of e plus log base e of m. And then the squared that would be on it right here instead goes here. Now, I said a bold statement. Those of you that used ln, it was not very smart. Why? Because right here you wouldn't have probably noticed that that equals 1. With the e's there, you for sure will see it. Oh, those are the same. That's 1. 4 log base e of x minus 1. And then, oh, so easy to right here lose 5% because you'd get this close, I'd probably be able to give you 5%. But that negative has to get distributed. Minus 2 log base e of m. If you had left it in parentheses, that'd have been fine, but a lot of you are going to not have a negative at the end, and that's all it would take. I think we should do another practice of that because I'm sensing a lot of glum looks out there that you didn't have this right. How many, be honest, how many of you didn't have this right? Okay, well, let's try another one like it. Ready? ln of 2x to the third over e m. Expand that all the way. So here's what you should have done. You should have said log base e of 2x to the third minus log base e of e m. And then you should have realized that that one can break up, and so can that one. And so now I break it up into log base e of 2 plus log base e of x to the third, and then the 3 has to go down in front, or I have to nick you for at least 5%. It's a minimum we can take off on a test. Okay, then I have a subtract here, and this parentheses is super important because that negative will get distributed then. Log base e of e plus log base e of m, and then this one can turn into a 1. That's the whole expand and simplify part. So your final answer, if I cross this off and just say that's 1, that's it. How many of you got it right this time? Okay, you still didn't get it right, then you should go back and watch the movie. What movie? I'm recording. I might be able to record even all 3 classes today so you can see different types of questions because I'll use different questions in different hours. Yes?
In log base e of 2x to the third power.
Yep.
I thought the third power is of all of 2x.
Nope. If there had been a 3 in the front, like let's say the problem had started like this, then that 3 would have been on both of them. If I brought it up, then it would go on both of them. But the problem started with a 3 right there, and without the parentheses, that means it's only on the x to the third. Yes?
The ln would also be negative, correct?
ln. You mean this one? Yeah, but I have parentheses, so I'm okay.
Oh,
And if you had parentheses, you'd be okay too.
I just put negative.
Okay, and if you distribute it out, then yes, definitely. You'd have a -1 and a negative at the end here. But again, I left this in parentheses, and you can do that too. But if you forget those parentheses, then you're saying that the negative doesn't go on that last one. So, yes.
What makes log base e of e 1?
Okay, if I have anything where these two numbers are the same, the bases, then the answer is the exponent on them. And since there's an imaginary, or not imaginary, an invisible 1 right there, that's why that's equal to 1. Okay, so the same thing would happen, for instance, if I said log 10. Well, what's the base if there's no base?
10.
So then what's that really equal to? 1. All right. Okay. And again, if you need more practice on that, I refer you to go watch a video from a different hour. I'll use different problems. Okay. All right, next up, let's see about, you've got a equation, you remember those ones with a sub 0 and a of t, and let's say this one, e to the kt, but let's say this one, I've already given you some stuff. I've given you that the starting amount was 20, and that it's e to the 0.8 t. Would you be able to solve? Do it.
We're solving for P.
Okay, so how could you solve it? You couldn't. I asked if you could solve it. Somebody said yes. Why can't you solve it? Two variables. All right, what if I said that this is about llamas and I want to know how long until there's 40 llamas? Now could you solve it? Yeah, because I told you one more thing, 40. And that has to go somewhere, and hopefully you'll figure out where. So the question is, how long till there's 40 llamas? So mostly this is testing, like, do you know what to do with the 40? So Arshawn, do you think it's in the T or in the A of T?
A of T.
Good. Dividing both sides by 20, and I get 2 equals e to the 0.8 t. Hopefully you got to that pretty quick. Amelia, finish it.
You would make both sides log with the base of e.
Log base e. Oh, you're putting in logs on both sides. I like it. Not many kids do it that way, but I like it. And then this part is just 0.8 t, because it could go down in front, right? Okay, so then I got, this is coming down, log base e of 2 equals 0.8 t. Now, for those of you that did a rewrite, you're still going to end up in the same place. Okay, now I'm going to divide both sides by 0.8. Divide by 0.8. Divide by 0.8. That's weird. Would you agree that divide by 0.8 is really divide by 8/10, which would be like multiply by 10 over 8? See what I'm saying? And that could simplify even further to 5/4.
But it would be fine to multiply by
Would be
0.8, or divide by 0.8.
Yeah, you could divide by 0.8. But you're going to have to do this and actually get an answer. Now, in this case, your answer has a log base e in it. Could you imagine a scenario where we would make it so the bases would cancel and you could just get a number? Okay. All right. Moving on. I've told you that you can graph anything as long as you use the XY chart. Let's see if you actually can. Graph that. Best friend in graphing. You can graph anything. Should you just pick any random number? Like, well, you can start with that. Like, let's say I put in 1. And then I realize I'm doing log base 2 of 5. Ugh, I don't even know what that is. So then I start getting more strategic and say, I don't want to put in 1. What do I want to put in? What would be smart?
-3.
-3. Where is it? I heard that first. So -3. And that makes that 1. Ooh, got a 1 in the argument. What's it equal to?
Nothing.
0. So -3 comma 0 is definitely a thing. Doink. Anybody want to know where the asymptote is? What would you put in to get the asymptote?
-4.
-4. Whatever makes that 0 gives you the asymptote. Do you even remember what a log looks like? I hope so, because I'm almost there. I mean, if I know what it looks like, I know it kind of looks like that. And now I just got to remember to make a few more points. So, like, give me something else strategic to put in here. 0 would work, because then I have log base 2 of 4.
What is log base 2 of 4? It's 2. So 0, comma 2. So that's at the spot 0, comma 2. And let's just get one more thing. Yes. 4. Because then you'll have a 4 goes in there. You'll have log base 2 of 8, which is 3. Look at that. I got 3 points. I got the asymptote. I'm good. Yes.
So, is the negative 3 as x equal to y 0 because,
When we put a negative 3 here, do you get this comes out to 1?
yes.
Anytime there's a 1 there, you have won the argument, and I have that dumb saying. You won the argument,
You get no.
the whole thing equals 0. So if I have log base 35 of 1, you got to know, oh, won the argument? The answer is 0. If you want to see why, I put an x here. I'd say 35 to the x equals 1, and you think and you go, oh, it has to be to the 0 power. That's why it's 0. There's a 1 there, and the answer is going to be 0. Okay. So much to learn, so little time. All right. Log base e of log of m to the 4 log of m, log base m, of e. Ugh. Complicated, but on this kind of problem, I'd always go to the inside. I'd start looking in here. And it doesn't have a base. And Mr. Server always said if it doesn't have a base, then that means what must be the base?
10.
All right. So I'm going to throw in a base 10 here. And then I'm going to make this simplify a lot better. I'm going to change that last E, you know, the E at the very end. Change that to a 10. I know I made the problem different there. Please change the last letter E to a 10. Because I want it to match up with this base. Because then it'll simplify down way better. Yes?
Is that m to the power of 10 or is that just m times 10?
Okay, good question. I'm going to put parentheses around the things that are the argument. Okay? That's the argument, and then this is the base. This is a base, and that's an argument. The first thing to move would be the what? The 4. Where would it go? Up to that power. And now, does anybody see something? I see something. Jacob?
Because the argument in log base 10 of the m and the base in log m, or log base m of 10 is the same.
So the bases are the same over here, so what's going to happen to all of this pink stuff? What does it equal? All of that pink stuff equals 10 to the 4th. That's the critical breakthrough. Why? Because the bases are the same. It would be a lot like, I'll break it out down here. If I just had this, m to the power of log base m of 5, you have to be able to look at those and go, oh, that's just 5. It's like that, except more complicated. And you look up here, and all of this turns into 10 to the 4th. And then there's another thing with bases the same. After you change all that pink stuff to just 10 to the 4th, do you see that there's another set of bases that are the same? Log base 10 of all of that turns into 10 to the 4th. Well, that's easy. What's that? That's just 4. The final answer is log base E of 4. Seeing lots of concerned looks, I'm going to give you another problem like that. You ready? Log base E of log r to the power of 2 log base r.
Is there a parentheses?
I'll tell you in a second. This is really hard to make these problems. Of 100. All right, so this is all in parentheses because it's the argument of that log base e. This is an argument, and this is an argument. There's a missing base. This is a base. And I think some of you will get it. You remember that kind of problem we did yesterday and the day before? I told you already, I don't have the time to do more of those. I already did it for 2 days in a row. So you may want to go back and look at a video on that if you need practice on that kind. That was the kind where you were given like half-life questions. If we have time, I'll try to squeeze one in, but. All right, here we go. This 2 moves first up to there. Why? Because you're trying to consolidate this down. And you're seeing these 2 R's and you're going, okay, I want to make use of the fact that the bases are the same on those. So I'm going to highlight it again. This whole area equals what? Just the blue part. What does the blue part equal? 100 squared. Because those bases are the same, the answer is right here. So then it's log base e of log of 100 squared. And then what's the base of that? It's not written, but there is a base 10 there. And then it'd be really smart if you knew how to make that into 10 to the power of something. What is 100 squared?
10,000.
And then that's really 10 to the power of what? 4. So then this is log base e of log base 10 of 10 to the 4th. So then this whole part, oops, I'm scribbling it out. I meant to be highlighting it. This whole part here is equal to 4. So the answer is log base e of 4. I'm just because I don't have room, I'm going to say ln 4. Yes?
Earlier in the problem, where did you get the 100 squared from?
The problem, this was the problem. The problem was written like this, and the only thing I did is move that 2. You see the red line? The 2 was in front. The 2 used to be right there in front of that log. Remember how numbers in front of a log can move up to the power on that log? There used to be a 2 right there underneath that scribble. That 2 moved up to the power. Okay. All right. Next thing. I want to talk inverse. Let's say I wanted to find the inverse of log base 3 of x. What's the inverse of that? Inverse? Yeah, we've done it on the last 2 tests, maybe 3. It's because inverses are a big deal. Remember how to do inverses?
You switch the X and Y.
Okay. So then I have x equals log base 3 of y. And some kids will think that that is the inverse. Nope. Know how to get the y alone?
You can rewrite it.
So you'd go 3 to the x is equal to, well, look at that. Now, if I asked you for this guy's domain and range, you really shouldn't look at its domain and range. What? If I asked you for his domain and range, you should look at this one's domain and range. And what do? We've had this on 3 tests now.
Flip the domain and range.
Yeah. What is the domain and range on the original one? Everybody sketch it. Just sketch it. You should know what a log looks like. We graphed one earlier this hour. Try to figure out what the domain and range of that is. Did you remember that logs kind of look like that? So what's the domain of this one? 0 to infinity. What's the range of it? The range of it is 0 to? No. Range of it is negative infinity to positive infinity. And then those just get reversed. The domain of the original one, which was 0, but it can't be 0, to infinity, becomes the range of this one. And the range of this one, which was all reals, negative infinity to positive infinity, would become the domain of this one. That's a quick reminder of what an inverse is. Had it on 3 tests, should be able to do that. And I think I can squeeze in the time to do one half-life question. So let's say you have 80 ounces at time 0. And the half-life is 10 hours. I'm not telling you a key piece of data here, but you can figure it out. Then I'd want to know
Sorry, what's that word saying is the time?
half-life, 10 hours.
No, on the chart.
That's 80. This is ounces.
Oh, sorry.
I'm just going to have you solve for K. Everybody just solve for K. Jacob?
On the test, are we gonna need to know?
I never answered that question. What?
Are we gonna need to know?
Oh,
how many rows?
can't answer what you have to know and what you can't have to know.
Well, you didn't teach us it.
So, I'm not telling you what's on the test, sorry. All right. Remember, you can watch other videos from other hours. I'd be happy to see some of you in the videos. Have a great day.
Thank you.
See you tomorrow. Do some practice.